Alright guys, I'm going to do classwork number 3. I think I'll do 1 and 2 for this one. Maybe I'll do 3 for another video, and then the general problem at the end. Should have your worksheet. You could have some scratch paper. I would definitely get the equation sheet also. That would be useful. Alright. So you can see that. Coulomb's law. So we're going to be using this equation, Coulomb's law, times Q2 R squared. All right. So it says two positive charges of 1 microcoulomb and 10 microcoulombs are separated. Those are positive. Are separated by a distance of 10 meters. R needs to be in meters. Find the distance and the magnitude of electrostatic force between the charges. Describe the direction in terms of the charges attract each other or if the charges repel each other. Okay, so for this one, and for all of them, I would start by just writing out your given information. 10 meters, good. R should be in meters. Got that right there. Our charges, Q1, just pick whichever one you want to, make Q1, Q2, all right? So why don't we make this one and this one 10. Okay, so these do need to be in coulombs. So these two are in coulombs, okay? And you might be thinking, well, how am I supposed to know that? Well, how am I supposed to know, what that is in coulombs? Well, you could just look it up on the internet. You've literally just type in 1M, capital C, 2C, and it'll tell you the conversion. Or use our chart here, okay? And right here, these are our conversions. So a milli, lowercase m, is 10 to the negative 3. So literally, it would be this, 1, 2, 3, or 0.001 coulombs. This same thing would be 1, 2, 3, so 0.01 coulombs. All right. K is going to be a constant. It could change depending on the medium you're using, but for our purposes, it will always be the same. Okay. Oh no, not that one's not squared, but times m squared divided by c squared. All right. When I put these in, I'm not going to keep the units, but literally just plug it in. So we have the force is equal to 9. I'm just going to make it like that. I'm not going to put the units in because it gets a little jumbled. So 0.001 coulombs times 0.01 coulombs. I guess I'll do it for that one. Right after I said I'm not going to put the units in. And then R squared, so 10 squared. All right. Just going to rewrite this. So I'm gonna type some information in. I don't have a calculator in front of me, so I'm going to use one on a computer because my phone is my calculator. I don't own it. I don't think I own any actual good calculators at my house here. So let's do 0.001 times 0.01. And then 10 squared is 100. So I'm just going to rewrite this as 10 to the 9th times what this would be. So this up here is going to come out to 0.00001 coulombs. This is going to come out to 100. All right. I'm going to change this to times 9E9. So I'm going to do this top one first. This is going to get me 90,000. All right. And then divide that by 100. All right. And we get the electric force between those two objects equals 900 newtons. 900 newtons, okay? And because this is positive, these two are positive, we know it is repulsive. So they push each other away. And this was number 1. Probably should have put that, number 1. Okay? Let's do number 2. Number 2 says a particle with a charge of plus 7.4, and you might be asking, what is that unit? Microcoulombs, is separated by another charged particle with a charge force of negative 3.6 microcoulombs by a distance of 1.4 meters. Find the direction and the magnitude of the electrostatic force between the particles. It's because of my coughing. So, R, 1.4 meters. It's in meters, which is good. Q1, it's going to be plus 7.4 microcoulombs. How do we convert that? Micro is negative 6. So 1, 2, 3, 4, 5, 6. If you do the math, you can just basically do 1 less 0 than what your exponent is. So 1, 2, 3, 4, 5, and then 7, 4 coulombs. Q2, negative 3.6 microcoulombs. That's going to be 0.01, 2, 3, 4, 5, 3, 6 coulombs, and that is negative. And then our K is the same. 9 times 10 to the 9th. Newton meter squared divided by Coulomb squared. All right, and now we're just plugging this in. Okay. So we get 9 times 10 to the 9th. 0.1234574 times 0.1234536 divided by 1.4 squared. So let's do it like last time. We're going to do the charge calculation first. Oh, and then keep in mind this one is negative. That is negative. That is important. Okay. So I'm going to get, this is just going to be all down here now. So I'm going to get, for this top part, 2.664 times 10 to the negative 11th. That's going to be times 9 times 10 to the 9th. It's going to be my next calculation. And then 1.4 times 1.4 gets me 1.96. All right, this top one times that. Let's see if we can do that. So I have 2.664 Okay, so this is going to get me, if you do this, I'm just going to put it back over here. This is going to get me, let's see, and it should be negative 0.1223. The answer key says, what is it? Oh, it's 1.3 times 10 to the negative 1 coulombs. So just because of the rounding, it's a little funky because of that, not a big deal. This is the correct answer. And then it would be an attractive force because we have a positive and negative. All right, so that's 1 and 2.